In today's video, I will give you a brief introduction about regression. Before we deep dive into regression, we have to understand a concept. What is that concept? It is the concept of variables. Now, we have two kinds of variables. We have independent variables and we have dependent variables. Now, what are these independent variables? The variables which are defined outside of the model is called as independent variables. A researcher cannot do much about these independent variables because these are not defined within our model. Independent variables are also known as explanatory variable. They are also known as features or the predictor variables. Mostly, independent variables are denoted by X. Independent variables can be either categorical or continuous in nature. For example, you may have categorical variables like gender, sex of a student, educational qualification, so on and so forth. And it can be continuous in nature, wherein we have the weight of a student, height of the student, and so on and so forth. That is independent variables. Now, what exactly is this dependent variables? These are variables which are defined inside of a model. This can be controlled to some extent by the researcher. It is mostly known as target variable or the predicted variable. It is mostly denoted by Y, and the main point in dependent variable is that it should be continuous in nature. It cannot be discrete in nature like independent variables. Hence, if we want to perform regression, the dependent variable has to be in the continuous form. Now, let us go and understand what exactly is regression. Regression is a statistical process for estimating the relationship between dependent variable and one or more independent variable. So it is a process of estimating a relationship between what? Between a dependent variable or the predicted variable and the predictor variable. It can be also called as the regressor and regressand, where your dependent variable is your regressand and your independent variable is your regressor. In this module, I will be talking more in detail about linear regression. Now, regression can be in the form of non-linear regression and linear regression, but most of the focus of this module will be on linear regression. Now, let us define linear regression. Linear regression is a process of establishing a linear relationship between independent variable and dependent variable. So regression was establishing a relationship between independent and dependent variable. It did not bother whether it was linear or non-linear. But in linear regression, we are trying to establish a linear relationship between the independent variable and dependent variable. Now, there are two different types of regression. Let us look at those different types of regression. So, we have simple linear regression and we have multiple linear regression. In simple linear regression, we have only one explanatory variable. That is, we only have one independent variable. That one independent variable is only affecting the dependent variable. Nothing else is affecting the dependent variable. So, in simple linear regression, we only deal with one independent variable. While in multiple linear regression, it has many explanatory variables. That is, we have a range of explanatory variables which are used to predict the outcome of a response variable. Now, consider a real life example. This is taken from the Kaggle website. and the name of the data set is California house prices. House price prediction is one of the most common examples of regression analysis. Now, in this house price prediction, we can understand the different independent variables and dependent variables. So, the median age of house, the total number of rooms, the total bedrooms, the number of people in the locality, households, median income, these are all our independent variables, and the median house value is our dependent variables. Now, if we are only dealing with a single linear regression, we will be using one single explanatory variable. Suppose I want to make a single simple linear regression using the median underscore income. Then we will have a simple linear regression establishing a relationship between the median income and the median house values. So that is simple linear regression. Now, if we take all the feature variables till median income and then build a regression model, then we have something known as multiple linear regression. So here clearly we understand the difference between a dependent variable and an independent variable. Basically, why is a dependent variable called dependent? Because the value of it is derived from these independent variables. And the beauty of regression is that you can even use the independent variables and find the value of dependent variable for the future. Now, if I want to find the housing price of the next observation, it is very simple for me. I know all my independent variables. I just have to run the regression and get the dependent variable, that is the median house values. So this is a classic example of regression. Now let us look at some more examples of regression. Now, the first thing that we are going to talk about is sales forecasting. Sales forecasting is done using regression analysis. Consider an example. Suppose your independent variable is all your customers which are met by your salesperson, the different reviews given to the customers by the salesperson, and everything else, combining and making your independent variables, and your salesperson's sales is your dependent variable. So this can be modeled using regression analysis, and it is a classical example of regression analysis. Now let us look at the other example, price predictions. Now we have different commodities. The prices of different commodity depends upon the demand structure, it depends upon the weather conditions, it depends upon a lot of other factors. So your independent variable is your consumer choice preferences, demand conditions, weather conditions, so on and so forth, and your dependent variable is price. So the model between price prediction can be made using regression analysis. Now let us look at another example, that is house price prediction. We have already looked at this thing, that is depending upon the age of the building, the number of rooms in the house, the number of bedrooms in the house, the locality of the building, all these factors affect the house price predictions. And using these factors we can create and build a model to predict the house prices. The next one is employment income. You can use regression analysis to find your appropriate income. So your income would be dependent on your educational level, your age, your sex, your occupation, and so on and so forth. Even calculation of insurance premium, all these can be done using regression analysis. Like if you're taking a health insurance, then whether you're a smoker or not, whether you drink or not, your different health factors, all these things are put together and then your premium is calculated. All these things are done using regression analysis. And then there is air quality index. You can also make air quality predictions using regression analysis. You can measure the level of nitrogen in the air, sulfur dioxide in the air, oxides in the air, and so on and so forth, and find out the air quality index in a region. Regression analysis applications do not stop here. It is a never-ending pool. It has its wings spread wide and far from all the sectors, from healthcare to IT, and so on and so forth. So now let us look at the different machine learning models which exist in regression. So the first machine learning model that we will be covering is linear regression. The next one is the polynomial regression. So basically linear regression covers a linear relationship between independent variable and dependent variable. Polynomial regression covers a non-linear relationship between independent and dependent variable. Then we have our lasso and rich regression. We have random forest regression, polynomial regression, decision tree regression, KNN regression, neural network regression, and so on and so forth. The list is never ending. In the future lectures, we will be talking about ordinary least square methods and the assumptions of linear regression. I hope the applications of regression, independent and dependent variable, simple and multiple linear regression ideas are clear for one and all over here. Thank you.